Hello, today's video is the part 2 of our trigonometry series where we will be learning the compound angle formulas. So there is the sine alpha plus minus beta formula, cos alpha plus minus beta, and also the tan formula. The tan formula can be proved from sine and cos, but we're going to memorize it just so we can do our problems a little bit faster. In this video, we will be looking at the uses of this formula and some special concepts. And to top it off, we're going to be solving some problems. So one of the most important uses of this formula is that we can find unusual angles from unusual sine, cos, and tan values using angles that we know. So for example, if someone told us to find what the value of sine 15 was without a calculator, we could express this as sine 45 minus 30 or sine 60 minus 45. It's honestly whichever one you prefer, but then we can use the compound angle formulas to solve and get something like this. So we get something like this, and then from here we know that sine 60 is root 3 over 2 times cos 45 is root 2 over 2 minus cos 60, which is 1/2, times sine 45, which is root 2 over 2. So we get root 6 minus root 2 all over 4. And this is the value of sine 15 using the compound angle formulas. So now memorize the formulas and try these three problems. Pause the video and see if you can figure out how to solve these problems. So for the first one, we can either use the complementary rule to write it as cos 15, or we can just write it as sine 45 plus 60, and then solve from there. I'm not going to show the work here, but eventually we're going to get something like root 6 plus root 2 all over 4, if you use the compound angle formulas. So on the next one, we can write this as cos alpha plus alpha, and there's also a formula for double angles, but we're not gonna use that here. That might be covered in a later video. And eventually we will get something like this. That would be cos squared alpha minus sine squared alpha. And then on the next one we can also use complementary again here and get cot 15. Or we can write it as tan 45 plus 30, which will get you, we will get something like 3.73. Of course, we still use the compound angle formula. I just put in decimal because it's easier than writing the version that has square roots and everything. So next we will be seeing some nice concepts or some interesting concepts that stem from this but are very useful for trigonometric problems. So the first concept we're going to be looking at is finding the maximum or minimum value of a trigonometric expression. So for example, if it's something like a sine theta minus, or let's say plus, b cos theta, what we can do here is we can try and bring this into one trigonometric function, either sine or cos, and we know that sine and cos have a maximum value of 1 and a minimum value of -1, and we can plug those in when we're finding the maximum and minimum. So we can see that, let's say we take A and B as the legs of a right triangle, and we take, or obviously root a squared plus b squared has to be the hypotenuse of that triangle, right? So we can take, we can divide and multiply this expression with root a squared plus b squared, so we get something like this. Wait a second. Plus b cos theta over root a squared plus b squared. And so we can see that a over root a squared plus a over root a squared plus b squared kind of resembles sine, and b over root a squared plus b squared somewhat resembles cos. And so we can take this angle as an we can take a variable here. It doesn't really matter what it is. We can say it's alpha. And so we can get our expression, and this will become root a squared plus b squared times sine theta sine alpha plus cos theta cos alpha. And we see that this resembles uh, cos the cos formula, so we can say that this will become root a squared plus b squared times cosine of theta minus alpha. And so we know that this part has a maximum value of 1 and a minimum of -1. So we see that the maximum value of this entire equation is root a squared plus b squared, and the minimum is negative root a squared plus b squared. And this concept is extremely important for like a lot of problems in a lot of different topics. So this should not be, but topic should not be memorized. It should be understood. Like you should be able to understand this and do this anytime instead of just memorizing how I did it. The last topic we're going to be looking at, or the last concept we're going to be looking at, is using the compound angle formulas more than once. So for example, if someone gave you something like, let's say sine 3 alpha, what we could do here is we could say that this is sine 2 alpha plus alpha, because if you remember correctly, there was no formula for sine alpha plus alpha plus alpha or sine alpha plus beta plus theta. So we can instead do it twice. So we can start with 2 alpha plus alpha, which will give us sine 2 alpha cos alpha plus cos 2 alpha sine alpha, like that. And then we can again change the sine 2 alpha and cos 2 alpha. We can use the compound angle formula again, and we can get, well, I'll just do it quickly, but sine 2 alpha is going to be 2 sine alpha cos alpha if you expand it, and cos alpha, well, it's just cos alpha, plus cos 2 alpha is going to be cos squared alpha minus sine squared alpha times sine alpha. And how I did them this quickly is I used these two formulas called the double angle identities, and we will probably be covering those in a separate topic. But again, you will get these same, like 2 sine alpha cos squared alpha minus sine squared alpha just by doing compound angles. And in fact, the proof to the double angle identities is using compound angles. So we can simplify this to 2 sine alpha cos squared alpha plus cos squared alpha minus cos squared alpha times sine alpha minus sine cubed alpha. Yeah, I think that's it. So if you like this video, please like and subscribe. If you have any questions or comments, please put them down below in the comment section. Thank you for watching my video. Bye.